All right, episode 30. Welcome back to the Attic Hour podcast. We're excited to have Zane Shady on the podcast.
Zane Shaden.
Joined with the regular, yes, that's the correct. Joined with the regular crew, me, Hudson, and Seth. Hudson has a list of the topics we're going over today.
I was going to say, this is episode 30.
Oh, yeah, episode 30. Yay. It's exciting.
32 weeks.
30.
32?
How's it?
Didn't we miss 2 weeks? We missed
Oh,
one for
and
Christmas
one
yeah.
of them was a
A
2
two-parter.
week
Well, that would take off.
one. We missed 1 week, and then Nathan
bonus.
did 2.
Either way, we're closing in, kind of closing on you.
Oh, yeah, that's true.
Crazy.
So I think we're actually 30.
Yeah.
Or something.
Probably 30 weeks. Yeah, 30
So
weeks,
close
30
to some part of
episodes.
1 year.
Yeah, it makes sense.
Over half of a year.
Yeah, what's the year? 50?
52.
52.
Ooh.
Ooh.
Over, under 1 year. How long we going?
Are we gonna
I
make
think
it?
it's going to be right at 1 year.
We're on a podcast by podcast basis here. Things could fall off a cliff. No.
Yeah.
No, they won't.
Well, maybe we should talk about Zane, our guest.
Give us a little.
Yeah, Zane, who, I don't know, tell us a little bit about yourself. Like, where do you work? Like, what do you do?
So I went to PFW for electrical engineering technology. Here, I just commuted basically up to Fort Wayne every day.
Nice.
And ever since I was after my sophomore year, I got an internship at L3 Harris Technologies up in Fort Wayne. And ever since then, I've been working there through the summer, through the school semesters. And then after I graduated, I got an offer, and I've been working there ever since.
And L3 Harris, they make satellites?
Yeah, so we don't necessarily make the entire satellite. We just make a lot of the modules that go on the satellites. Like, for example, something you can actually look up right now. There's a organization based kind of on NASA called NOAA, NOAA.
Oh, I've heard of that.
And NOAA has live feeds. We make specifically like the imager of the satellite, for example. So if you look up like ABI or NOAA ABI live feed or something, you'll be able to actually like find the live feeds from the satellite of like pretty much everywhere, like in the entire like hemisphere of the U.S.
Really?
And kind of down to South
Really?
America
That's just
area.
public
Yeah,
access?
yeah. You can
Really?
watch it basically in real time.
So you essentially design and manufacture like the camera is.
Yeah, it's
camera.
basically just a large camera.
Okay.
Yeah,
Wow.
and it looks at very specific like wavelengths of light and stuff.
So it's not like an optical camera like you'd think on a
It's-
phone. It's like,
Yeah, it's more advanced.
like a
than that.
radio or whatever they call
Well,
that.
It looks at like we have basically certain like specific things that look at very specific wavelengths of light, and those wavelengths of light will actually tell you like, oh, there's a fire here, or there's certain clouds are here, or there's like ice here, or like you can basically see different things.
So this is
in
is
the
this for like
atmosphere.
weather?
Yeah, yep. This is the weather part of the business.
Gotcha.
So you can basically you can see all kinds of different things, just based on specific wavelengths of light, and you can actually go into each individual wavelength of light that the satellite actually views and look at the live feeds of each of
Do you
them.
have like a rough number of how many that's tracking?
So I think there's 12. So there's different kind of like tiers of like the wavelengths of light. One is like long wave infrared, short wave infrared, mid wave infrared, and like visible near infrared. So there's kind of just that framework, and then they basically we have multiple channels like around every one of those kind of areas. And so yeah, you can basically look at the live feeds of each and every one of them, and NOAA's website actually has a description of what each one's purpose is. So it's honestly super cool.
Yeah, I don't know if our internet will load up here. That's the downside of it in the
Yeah.
attic. We gotta get our own router or something.
Yeah,
up here.
very
Yeah.
very spotty. Oh yeah, dude, we could just get one of those Wi-Fi extension things. Is that a
Well,
router?
we kind of have one up here, but I don't think it works.
Oh.
We're not even connected
It
to
needs
it. So.
configured. I think it's back on your parents. Yeah,
Okay.
whatever.
So what do you do at L3 Harris? What's your job?
So I'm in the specialty engineering department, as is in the name, is kind of just more of the specialty area. So it's not like specifically electrical engineering where we design things. It's not mechanical engineering where we design and like prove things and all kinds of stuff. It's kind of a lot more of an applied area. Like we have like, I'm specifically like a component engineer where I basically look at electrical components and in multiple different aspects. Like, so we have a failure analysis lab and basically in the basement of the Fort Wayne site. And we basically just have a bunch of things like a real-time X-ray, a scanning electron microscope, all kinds of different other microscopes and kind of crazy stuff that we basically use to go through, like if something fails, like if we have a specific component or something that fails, or like something on a circuit board, and they're like, hey, this failed, we want to take a look at it under the X-ray, for example. And then we just chuck it in the X-ray, we can get a live feed of it, take pictures of everything, and then just pull it out and go on
Start
with our
testing.
days. Yeah.
Wow. So you wouldn't do too much of like the actual design. Once you find a problem, you're just proving different scenarios and trying to find issues.
Correct.
Where you're wrong. Okay.
It sounds like that job would have quite a wide variety of kind of what you do.
Oh yeah, it is a really good big variety, and that's kind of why I like it, because I don't like doing the same thing over and over and over and over and over again. So it kind of helps. I'm basically like 50% down in the lab, 50% at my desk.
Nice.
So I got a pretty nice mix.
Yeah, that is.
Yeah, that is pretty ideal. You were talking a little bit about you have like some technology project ideas that like you have, or what do you mean by that?
So something that I'm kind of working on right now is, so I just recently got married, and
Congrats, by the way.
Thank you. I hope Phoebe doesn't watch this, or I don't know, when do the episodes normally come out?
It'll be like a week and a
This will
half.
be, yeah.
Okay, I should have it done by then. But basically, I'm making a project for her birthday.
Oh.
And it's basically just going to be a little microcontroller that connects to like basically a little mini Kindle display.
Okay.
And I'm going to have it connect to our Wi-Fi at home and connect like a number. Like I'm going to buy a phone number.
Okay.
And then
Yeah.
basically be able to like text the phone number certain things and have that display say certain things.
Oh wow.
So
Like a text to speech.
it's yeah, speech probably maybe in the future, but basically just for now being like, hey, love you, or thinking of you, or
Right.
just anything and everything. And that way it's kind of just something like, ideally I'm going to have it basically be small. I have a 3D printer, like 3D printing enclosure for it, and have a battery bank and everything, so that way it can be carried around anywhere, and it's just kind of, it'll just like permanently display the last thing that I texted that number or something.
That's
like
so
that.
cool.
That is.
So she can carry this little thing around with her, and anytime she wants, she can view the most recent message.
Yeah, so kind of just like like I said, just like a thinking of you, or just like
And you can
Work's
keep
going
updating
good.
that message.
Yeah, and that's the end goal of it. So it's just kind of things like that. She actually gave me that idea this week, because I was like at work, I was just sitting there, I'm just like, I really want like a project or something to work on.
Yeah.
And I was like, I don't know what to actually make, because you can make like so many, like infinite number of things.
Right.
And so I was like asking her, and she's like, you can make something for my birthday. And I was just like, oh, that's a good idea.
That's a really good idea.
How romantic.
So where do you work on this? Like, can you work on this at?
It'll be at home.
Oh,
So
okay.
like I've got, so what I ordered some little microcontrollers,
Okay.
and then that it's called an e-paper or e-ink display.
Yep.
And that's basically what the technology is, that Kindle's display, where it's like it doesn't actually have a backlight or anything. It's just like
It's using the room light or whatever, and it just
it basically, the way it works is, it basically, the screen like has a bunch of like little dots in it, like inside of it, and there's a place like behind the screen where basically voltage, like it applies voltage in specific areas and basically excites those little dots, and the dots turn black whenever they get turned on, basically.
So you wouldn't see it in a dark room.
No.
Like, there's
Yep.
That's really cool.
So it literally just changes the color of the actual screen, but there's no light or anything that emits from it.
people have tried to make phones with these screens, right?
Yeah, so there is, the thing with that about them is because it's not like a pixel or anything. It's like, it's actually a real thing that like changes and moves basically whenever you put a voltage on it. So because of that, it has a lot of like a response time issue where like typically if you're on your phone, you can scroll, it'll scroll like immediately. It has a refresh rate and everything, but the refresh rate of like the e-paper displays are like 1 hertz.
Is it considered a refresh rate?
Yeah, it
Like,
gets
is it the
to
same?
the area where it's like almost not, because you can't. I'm not quite 100% sure about the technology, but I don't think it's like 100% like reliably 1 hertz. It's just kind of the average like response.
Gotcha.
So
So there's a physical thing happening. It's not like
yeah,
it's
it's
a physical voltage causing something to actually like
physically
rise.
change. Yeah, it's basically changing. So by default, with like no voltage applied, it's white, and then it basically, depending on what image you want it to display or whatever, it can basically just turn those white like blobs into black.
Wow.
To
That's
actually
sweet.
make the display. So one thing about it is once you've like applied the voltage, it stays that way until I'm not, like I said, I'm not exactly sure how the technology works, but basically once you turn those pixels black or the pixels black, they'll just stay black until you tell them to not be black without consuming any power or anything. So you can
very
have
power
them just
efficient.
yeah. So
It takes a voltage to turn them on and off, probably.
yeah, yep.
Wow.
So then you basically just apply that voltage and it sucks like no battery. So that's kind of the goal of why I wanted
Alright.
to use that, is because if I want to have its own like thing with a battery bank, using the least amount of power to actually do it so it can last as long as possible
Right.
is kind of something that I was thinking about.
You said they tried to make phones with it. Were they ever like remotely successful?
No, it's
There's no color either.
Yeah, yep. So they do actually have some e-ink displays with color now.
okay.
They're still really limited. They're nothing near like what your phone can display. But
They actually have some with cameras on
Bert,
too, don't they?
Bert, can you pull the picture?
I don't even know how that. I guess it's probably so
It's-
bad.
The market for this phone would be people that are fed up with smartphones.
I mean,
It'd be
have
sick
you
of
have
them
you
by
seen like those
phone.
minimalist phones?
It'd be like that.
It would be similar.
Not like the Nothing brand. Those are still like for the typical market. But this would be for people that don't want an iPhone or any phone
Okay.
like that.
basically the dumb phone people.
Yes, yeah.
Because I've seen phones that they kind of look like a smartphone, but like I know something with the colors just like different. It's all like black and white
That's
kind
probably what
of,
this is.
and like the camera
Yeah.
is horrible.
Yeah, it's
Is that what this is?
Probably.
yeah. It would
Yeah.
think of
What-
like an
what's
etch.
the
Think of
brand?
a computer-driven etch-a-sketch. Like that's kind
Oh,
of
really?
what this built.
Yeah, that's basically honestly
It's-
that's pretty much what it is.
Yeah, that's what the
Whoa.
screen would look like.
Yeah. So
Whoa.
it's not very high resolution at all. Like it's like, I mean, pretty much the main reason why it's used for Kindles is that one, it doesn't take any power once you've displayed the image or all the words basically, and two, it doesn't have a backlight that hurts your eyes.
Yeah.
And what was the last thing the thing that you had just mentioned, Seth?
Minimalist. Like
yeah,
you can't get
and-
distracted.
Yeah,
like,
and yeah, it's basically just like dead simple. You don't really have to worry
Okay.
about it.
I think that is what
did
I'm
you
thinking of.
see that MKBHD video where he
That's-
had because you can actually get apps on some of them. Like they tried to like actually
Yeah, I
make
think you
these
can get
as a
Instagram and
production,
stuff too.
but it's like you said, one hertz refresh rate, not great.
Dude, I could see myself Loki get one of those like someday. Once they develop a little bit more, once the camera gets better.
As your main phone though, I don't know. I feel like you get stressed out. Like you have like some important work thing you're trying to do.
I
And you have
mean,
to like
just
get to it
can't-
fast.
yeah.
And, like you're
Well,
Yeah.
camera would be. So are you saying like when you could see pictures on the phone better?
I mean, low-key, I just want like I don't know, I see the appeal of having a dumbed down phone, whereas like your camera is still like the same, it's still really good, but and you can text, you can look things up, but like I mean, I don't know, just have less ways to be distracted, I guess, or to burn time.
Yeah. Yeah.
Hmm.
It'd probably be a bit till anything successful like that.
Right?
comes
Yeah,
out.
it'll probably be
especially
a few
using
years.
that non-backlight technology.
Right,
With,
when-
like,
I
you wanna
think
have
that's really
colors and
interesting.
Stuff, like,
Wouldn't hurt your eyes.
That could be your next one. Is make an e-ink display phone with like an iPhone
Oh my.
11 camera or something.
Not a daunting task at all.
I mean, they do make cameras like that you can technically like hook up to these like microcontrollers and everything, or like Raspberry Pis
Like
and
decent
stuff.
decent micro
Yeah.
cameras too. Either.
Like whenever I was in college, we actually had a class where we were required to buy a Raspberry Pi and a camera module, and basically the entire thing was like the entire class was just taking images and manipulating them by their pixels. And basically doing things like edge detection, where like basically just based on the image, like if I took an image like boom right here, this table, it running the edge detection algorithm could like see the edge of the table
wow.
and like highlight it. And so that's basically the entire class was basically just image manipulation with code. So
That's crazy.
what was that? What language did you use for this?
Python,
Okay.
and it was all on the Raspberry Pi itself. So it's this little tiny mini computer, but you can actually load like basically a version of Linux on it.
Right.
That's really light, and you can it has HDMI, USB ports. You just hook up a mouse, keyboard, and monitor, and you can basically just use it as a little computer.
Wow.
So
Sick.
That's so cool. I'm taking a Python class next semester. And I'm kind of excited, but I don't really want to learn another language.
Well, what do you normally use?
Yeah, how many languages do you know?
Well, that's the thing. It's like, that's the thing. I've written programs in C Sharp, VS or Visual Studio. Sorry, not Visual Studio. Visual Basic and Visual Basic Application, and then Java. I think those are the main four. And then GML or Game Maker Language, but that's kind of
You've done VBA.
a lot of VBA.
Yeah.
I don't know.
Are you making Excel macros or something?
Oh, we can go into that in our own time, but yeah. You could say yes, lots and lots of Excel macros. No, Python. Yeah, I heard a lot about it. Like, I think it can pretty much do everything at this point.
I mean, like, it's got so many different libraries and all kinds of other crap.
This is what they're using for a lot of like ML now, right? Machine learning. Is it in Python?
That's a great question. I think probably a lot of what they're doing, or of why they're doing that, is probably because it's just easy.
Yeah.
Like, it's it's a dead easy language. You don't have to worry about syntax. Like, syntax, there's just like no syntax. Like, you say like this, like it's just dead simple. Like compared to like C# or whatever, you gotta have a semicolon after every line, or
brackets.
I had a class on C in college, and that's like you gotta like work with binary in some instances of like manipulating individual like bits for certain things. So
it all starts somewhere. Yeah. It is crazy. Like, does trace like the line of like computing, like how some genius got from binary to assembly and then assembly to this, because like at one point somebody was programming with probably a 1 and a 0 or something that equated down to a 1 and a 0, and somehow they turned that into making that into letters and combinations of letters, and all this stuff has to at some point trace back down to a 1 and a 0.
It is insane.
Yeah.
It's
So-
that's absolutely
Yeah.
wild.
Yeah.
like, for example, C is like a really low level language where it's like is really close to like assembly,
Right.
which is basically just like one step. Assembly is like one step away from like the 1s and 0s, basically.
Does it compile directly down to assembly?
Correct.
Okay.
Yeah. And
Compiling, for people that know, when you write in a higher level language, something that looks so higher level means you're getting closer to something that you could just write in a doc.
Like Python or something.
Yeah.
So higher level is more human readable, low level is more machine readable. So that's like the stack. When you compile, it means you're going down the stack from one level into a lower level.
You're moving down.
correct. So
So
then
you're making your humanly readable, you're more words into more numbers.
yeah,
kind of.
you're compiling it down into a language that's used, and so a lot of them will compile sometimes through multiple languages down to machine code, which is 1-0.
Yeah.
So like with AI, does AI just use 1s and 0s? Like, does it all compile down to that as well? Like the same with the computer?
Yeah, in essence, anything that's computed has, like, a processor wouldn't understand the word the or a until it's down to a 1 and a 0, and even in that it needs context probably too. So yeah, everything is on some racks and racks and racks of just computers, like kind of what we have, but configured differently, and they're in a different shell. It's running like a computer, and it's all back down to 1 and 0.
So AI is still like running like a computer, like from 1s and 0s?
Yeah, just basically at all the data centers. Like they have all the. I mean, they're taking all our RAM.
Yeah.
But
Our GPUs.
yeah, but yeah, in a way, it's basically just like the whole AI thing is like basically just like they're doing like ChatGPT is basically just like remote processing your question. It's basically the same way as like what Google does.
You might
But-
break down remote processing to them.
Like basically whenever you Google something or like you send something in ChatGPT,
Yeah.
you basically are sending that text right there, and then when you like press enter, it'll basically take that text, like ship it over the internet to ChatGPT's warehouses or whatever, and it'll like basically take their large language model and basically process it all and basically just spit crap out. So and
you're-
then
yeah.
sends it back to you.
Your computer isn't running ChatGPT. All your computer has is just a portal to talk to ChatGPT.
Yeah.
But ChatGPT is
Exists
in Montana.
at the data. It
in
exists at the
some
database.
absolutely humongous. Or do you think of the Google's or the data center that just built in Fort Wayne?
Yeah, yeah.
They have these huge data centers, and all you have on your computer is just a portal.
To speak with that data center.
Yes, yeah, to send a request. So you say, "Tell me a funny story about dogs and cats," and then that text of string gets sent to their data center, gets chopped up, and then it gets processed there on their. They have to pay for all the electricity, everything that it takes to do that, and then they send whatever comes out of that machine back to you, which is just another string.
On a period of half a second.
Right. Yeah.
It's crazy.
Yeah.
Yeah.
So like does like ChatGPT for example, does it actually so all it's doing is processing. It's not actually thinking, even if you use like the quote unquote thinking mode like in ChatGPT.
It's basically predicting. Like that's basically all it does. Is it like the reason it's called a large language model or an LLM is basically because it's taking language. It's just processing through language and looking at all other instances of language. Basically, like if you ask like, how do I get to work or something, or Google it, or like, how do I drill a hole in something?
Yeah.
And it'll basically look at all other instances of where things talk about drilling holes. And it will basically just be like, oh, based on all these massive amounts of other experiences of drilling holes, I think you should drill a hole like this or something. It's basically just taking other instances, processing through them, and predicting what it thinks that you might want.
So is it almost just like pattern recognition?
Yeah.
Basically.
A way you can kind of think of this, and you can correct this too. You know when you're texting and you say hi, and then you at least in an iPhone you get 3 words.
Yeah, yeah,
up.
yeah.
You put the next word, the next word, the next word, and then if you keep going, it kind of writes out a story. In essence, these LLMs, they're doing the same thing, except they're significantly smarter. But they'll start with a word that's based on the tokens, which is whatever.
Your prompt.
I need to go down a level.
Dumb it
it's-
down for us.
What it's
too
it writes progressively like this. So it gets this sentence, it puts that sentence back into itself, and then it predicts what the next word would be. Like Zane said, based on everything it has, this word's probably going to go next. And then it puts that back in, and that's a little longer, and then it says, now this word's probably going to come next, and this word's going to come next, and all that's based on the unbelievable amount of data that it's been trained on.
Wow.
Oh my
And
goodness.
it's always learning, so every time
Right.
it does it.
But
it's
all of this
faster.
is done in the context of your initial query.
So that's why sometimes like whenever you ask ChatGPT a question or something and it gives back an answer, like a long response, an answer, but it's all incorrect, but like it's always 100% confident. It's because it's not actually thinking. It's because it's just recognizing a pattern and pulling from other data to spit out a response.
Basically, yeah.
This is like
there's-
this is where go
Yeah,
ahead.
especially there's the whole phenomenon of like how AI, like especially with like LLMs, it hallucinates. Basically, it like will make up like a day where someone died, like a political figure or someone died whenever they're actually still alive. So it's just like things like that. I honestly don't know how in the world things like that happen. It just does because it's just trying to predict things. It doesn't have a brain. It can't think through anything. It's just like Seth said, basically just going through, just like feeding everything back into itself and just predicting.
So
what
if
the
it gets
next...
one part wrong when it's feeding it back into itself, it can just go off that and make a whole thing wrong probably.
Yeah.
And then just believe itself in a way maybe. I don't know.
The way. So what? I mean, in an essence, you can trace a human's brain back to something somewhat similar. Probably not. We're probably levels more complex within this. But why people say that these are such alive is because they can learn, and their brain, if you were to actually look at them and you could like get them into a graphical version, would be neural networks. So it's neurons literally chain reactioning and firing through, and their output is what you get.
I'm sorry, are you talking about the human brain or
No,
AI?
this is
Like-
yeah.
So the thing is with like, it bothers me with the whole like AI craze, where it's like artificial. It basically just means artificial intelligence, but like in reality, AI has existed forever. Like there's like before like the second you try to predict anything, You're basically using, it's also called machine learning, where you're basically just using a machine, which is just processing ones and zeros to try and predict something. So like we've had autofill on phones and whatever for so many years before the whole AI craze.
Yeah.
That's all just AI. Like Siri, like Cortana and like Windows 10 and everything. They're all just like effectively their own little AIs at a much lower level of like functionality. But
So what was like the line that was, or like the threshold that was passed whenever people were like, oh, we've now invented AI? Like maybe like, what was that, like 7 years ago or something?
it's not real.
It's not
Like
real?
that, it's like I say that more like in quotes. Like they just decided to call it that because they found a good product, and they basically were just like, oh yeah, this is AI. It's like basically like what you see in the movies.
Yeah.
Like that's basically what their goal of marketing it as basically was. And then now, of course, we're today where it's like, oh, AI this, AI that.
Yeah.
We need to do AI here. Like
It's meaningless at
Yeah,
this point.
yeah.
So
exactly.
probably the first like AI was the first computer, right? Or before that, even? Yeah,
more just the basically kind of just any computer trying to predict something. Like
Yeah.
pretty much that's basically what you can break it down to. It's like if you're using a computer to predict anything at all, it's technically using like machine learning where the machine is trying to learn to predict something. That's basically
Yeah.
kind of the way to think about
So
it.
like 7 years ago, whenever they started like talking about it as AI, it wasn't as much as like they made a significant step in the development of that. It's more like it was a marketing thing.
Well, also OpenAI, right? Whenever when they launched ChatGPT, that's a big step, right? Like they didn't have anything publicly accessible. before
So Chat GPT, the GPT is generative pre-trained transformer. I believe that's right.
Bert, can you look that up?
Generative pre-trained transformer. So that's actually a model of, I guess you could say, artificial intelligence, and it's just the current way we do it. And I think that the creation of this generative pre-trained transformer, that is like when it like start to like people are like, oh, okay, this thing's pretty capable.
Generative pre-trained transformer. You
Yeah,
were right.
so this is generative as in like it can create things that don't exist, because a lot of the stuff that spits out of, it'd be one thing if it could just find a bunch of little snippets of stuff and put them together.
Yeah,
That's-
copy and paste sources.
Right.
That's like what I do in my.
but it's
papers.
actually creating something that doesn't exist. I mean, maybe like when you write a paper, technically something somewhere might be the same, but so that's where it's generative. It's pre-trained because all the data, it's already thought through it. Like they have to make this model and they have to pre-make all these networks to get them somewhere really close. So it's pre-trained before they release it. And then transformer is somewhere on how it thinks and like all that kind of recursion and da 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 da. But so I think once, we should probably look this up, but I think it's safe to say that once they kind of got to this model, I think that's the right word for it,
Yeah,
model of AI, that's when they were like, okay, this thing is crazy.
it can actually like it. I mean, and in some instances, it is really useful, and that's kind of what they were banking on. It's like, oh yeah, we can actually. This is actually a useful instance of AI. So then now they're just naming everything AI.
Yeah.
And then now previously people that just use standard machine learning like predictive text, like if you're texting or something that's trying to predict the next word, they're now labeling that as, oh, it's AI powered, when in reality it's always had AI and machine learning.
Like
but they're just-
what was it, the iPhone 15 or something that launched Apple Intelligence, which is literally just like another Siri.
Yeah.
yeah. So
I think so many people, even myself in the past, have like just thought of like ChatGPT and like quote unquote AI is just like a giant like you see in the movies, like a giant brain that actually thinks through things. I just never thought about it before.
Yeah, I mean, it's not all wrong. I think it's just misleading.
Okay.
Like all GPTs aren't connected. I mean,
They're
Claude, Gemini, those are all like probably very unique. Well, actually, yeah, they're not. It's not one hive mind. That's all like
Yeah.
they're all kind of their own, but they're all GPTs.
they're all kind of in the same model.
They're all the same type. They're just kind of trained
But
differently.
DeepSeek is different, correct?
I don't think so. I think it's also GPT.
I honestly have no idea.
Yeah.
I thought I heard something about like DeepSeek is
might
made
have-
without NVIDIA chips.
Yeah, but that would have just been how they process through the information.
Okay.
Yeah. So they probably did it with some Chinese knockoff of NVIDIA.
The Temu version.
I think the only thing I've really seen of DeepSeek is just someone asking you if Tiananmen Square.
Yeah,
happened.
Social
What'd it
credit.
say?
Doesn't.
There's some models of it, at least an early model, that it will start typing out the answer, and then by the time it gets through the answer, it's like, oh wait, I can't say that, and they'll just redact everything.
No.
Like so,
That's
yeah.
DeepSeek is not a GPT developed by OpenAI. It's a separate AI company based in China that creates its own, often open source models.
We go back up.
Yeah, I think it's basically while it uses similar transformer-based technology, it differs from probably a different architecture, kind of same.
Architecture was the
Yeah.
word that's better than model.
Mhm.
GPT is an architecture.
Yeah.
That's weird,
That's
man.
architecture is like how it's designed, or like
Yeah.
its makeup.
Yeah, you can actually look back at older versions and stuff. It's really interesting. And what's cool is GPT won't be the last one. Like they'll make
Oh yeah, no, they're
GPT.
definitely
They're
more.
probably already trying to make something that's. Who knows what that acronym's going to be?
Yeah.
If they last that long.
I'm surprised. It's developed by open source.
So
I wonder if it's thinking of Chat GPT.
Yeah, I think
It's
it
not
is-
a generative pre-trained transformer model developed by open source. Maybe GPT is just a term made by OpenAI. I don't know. This is all three brown, one blue. Whatever
Yeah,
he
I
made.
know.
That, like
oh
a
look, the
4-part
AI
video of it.
overview pulled from Reddit. Oh, that's nice.
Yes.
That's a problem. Yeah. So what? I guess I know hardly anything about like quantum computing, but like how is that going to affect like all of this stuff? I don't know. I've just been like because from what I understand, quantum computing like expands it from ones and zeros. It's like ones, twos, threes. Like it's like all of. It's more numbers, and so like there's more possibilities. It's more powerful, more I don't know.
Yeah, well, and I think the biggest thing about quantum computing is that it's basically more things at the same time. So like their whole thing, instead of like ones and zeros of bits, like what normal computers use, they're called qubits or quantum bits, where basically it's like the way it processes is it like basically thinks of both, like basically a 1 and a 0 at the same time, and then they can there's like a thing I this is like a Rubin thing.
Yeah.
Okay.
I got to the point where I kind of understood it, but this was a couple months ago, and I had to forget everything.
Ruben's gonna blow our minds when we have him on the podcast.
I remember, Seth, you were kind of explaining it to me just because I did not know anything, and it helped a little bit, but I'm still way lost.
Yeah, and then like these qubits basically can like become quantum entangled with each other, and they're basically like, I don't know exactly how it works, but basically it's like magic. And then
Straight out of a movie.
yeah, it like literally it can think of basically a bunch of different things at the same time, rather than technically like the processor on your phone is technically just going through ones and zeros like incredibly fast.
Mhm.
Like so the way basically like things like processors and stuff are like kind of like qualified is basically by their hertz. I mentioned like the refresh rate of the e-ink display we talked about earlier.
Which we should take a second just to talk about how crazy just traditional CPUs are.
Yeah, I know. Yeah, that's basically what I'm getting to here. So a hertz is basically one kind of action every second. So 1 hertz is basically a clap every second. Then you
Sure.
get 2 hertz and
Yeah, it's faster.
and then basically it just keeps scaling up higher and higher and higher. And basically, so like basically what the level of like your desktop processors are, they're in the level of like 3 to 4 gigahertz, which
Oh, wow.
so you gotta go up through like these are like engineering units where so kilo is 1,000, so like a kilometer is 1,000 meters.
Mm-hmm.
Then you have mega, which is 100,000 or a million, sorry, and so then like there's technically a megameter. It's 1,000,000 meters. And then there past that is a giga, which is like 1,000,000,000. So basically what your phone processors are doing is they're processing things at gigahertz, which is billion times. They're going through billions of ones and zeros every second.
That's insane.
That is
And not
wild.
just one and zero, like I don't know.
Parallel.
Yes, like
Yeah.
tons of like thousands, or probably way more than thousands.
Yeah, like it goes through like it's just insane how much.
Every hertz, it technically it's Yeah, okay, that's
Yeah.
right.
Yeah.
Anyhow, it's doing billions of things in a second.
Sure.
Like casually in the background.
Yeah, and you don't even think about it. You're
Right.
just scrolling Instagram.
Right.
And you'd think like, oh, if it's doing that many things, how does the battery not just run out like instantly?
Right.
Yeah.
That's just like the way the technology is. It's just like actually insane that we can take our phones out and like Google things like and do all of this stuff and process through all these things.
And be on it for 7 hours before it dies.
Yeah, exactly. So like
And the fact that used to, like, in the 60s, that was never possible, but it used to take a whole
Yeah.
room to do one
Mm-hmm.
action at a time, right?
yeah.
That's crazy.
So yeah, and like how they make it is another thing. Like how in the world do you make a processor? Like, I mean, I'm just curious. Like, how do you guys think that they're made?
Phones?
Or just
Right,
like,
like just the
just
chip,
the
like
chip
the-
processor, basically.
I mean, I all I know is that it's NVIDIA.
I don't know.
It's just magic.
Yeah.
I mean,
I
basically.
I mean,
genuinely
it's just
have
a bunch
no
of
idea.
it's just a bunch of micro. Everything's just so
Yeah.
tiny.
So
Is it like robotic, like using...
yeah. Everything is like so precise and like completely robotic. Like literally, you cannot even dream of having hand like proficiency.
it's to the point where you
without-
can't see it, right?
Oh
Or
yeah, yeah.
feel
You
it.
can't even see it. So that's the cool thing. You mentioned see it. The actual technologies that they're making, basically, they're. I need to break down a lot of different things. Basically,
Abstraction. Everything. All
Yeah.
of computer science is built on this like high-low level, and
Yeah.
like as you go
Yeah.
down, you descend into layers.
so basically, the extreme foundation of a processor is an element called silicon.
Okay.
A silicon is a semiconductor where it can act as an insulator where it doesn't conduct electricity, and it can act as a conductor where it does conduct electricity.
What does that have to do with Silicon Valley?
That's kind of what's named.
Well,
after, right?
that's basically what it's named after.
Okay.
They started making a lot of silicon stuff, and it just got called Silicon Valley.
Gotcha.
Another kind of like AI trend, they just named it because that was the trend.
Okay.
But yeah, basically, so you basically use silicon as semiconductors, and you basically just make a bunch of like you can basically turn them into like logic gates, where it's like this and this. If you have this and this, then that is like basically if you have a yes and a yes, that'll be a yes. But if you have a yes and a no, it'll be a no, or a no and a no, it'll be a no, or a no and a yes, it'll be a
But
no.
like, what is the
Like,
physical thing this is
The
happening? on?
physical thing is like literally like basically silicon, a material that will basically
Let it-
conduct
yeah.
one way but block electricity the other way.
Gates.
Yeah.
It's just gateways of letting electrons pass through this point based on the
So
stuff that
they're
comes
like
into that.
opening and closing at all times to like...
Not physically.
Yeah, it's all like electrically and well, I mean, if you break it down technically, physically, like it really goes down to like the way electrons move in physics.
Okay.
Basically, so the extreme basic like silicon can have is basically just a diode. A diode is basically electricity can flow. Like let's say I have a diode, electricity can flow this way, but electricity cannot flow that way.
Sure.
And how does it do that? It's just magic. Like,
So you can create pathways that electricity can
yeah,
flow,
yeah,
but
but
this is
can't
all-
flow backwards.
Yeah.
Like if you apply
Like a
voltage-
one-way street.
Yeah,
Yeah.
basically it's a one-way street. So then you can basically combine these. You can combine diodes together, and basically there's this whole process called doping. I'm not going to get into that. That's really into the theory. Basically, you can combine other elements of silicon to get it to do different things.
Okay.
And basically that's how they make the gates. Is they basically put diodes together of different materials and
But how you go from a bunch of microscopic diodes and silicon forming pathways to actually showing up on your screen is a
yeah, I know
Well, like,
exactly.
how
don't
how
know
big
how
are
to
these
get-
chips? Like,
So the actual chip's probably like on your phone.
probably about the size of an
processor's
Apple,
probably about like that
like
big.
an
It's probably
SD
half of
card.
On
Yeah.
a phone, they get bigger. Like a CPU on like your computer is, I don't know, an inch by an inch.
yeah, maybe a little more. Yeah, an
Okay.
inch and a quarter, inch and a half by an
Sure.
inch. And a half.
But a lot of that is just interfacing to get to the
Mhm.
motherboard. The actual chip size is small.
Yeah.
dude, if they have robots that are like that precise and that like incredible, why don't they use those like as surgeons?
Wow.
Well-
Wait, it's not really. It's more like chemistry. isn't it?
Yeah.
Yeah,
So
that-
a lot of
yeah.
it is chemistry. So like, it's like it's so insane. Like so, just to give you the scale
Chemistry
of like how big, like Seth had mentioned the gates that they use to basically
Yeah.
control where the electricity goes through. If you had to guess how small the gates are.
I mean, what is your measurement here? Are you measuring in molecules or
your measurement is like atoms?
Atoms?
No
Like,
way.
Yeah.
Oh
so
my
like the thickness of like the silicon technology they use for a lot of like modern processors is like you're getting to the point of like 5 to 7 nanometers, which so then we're going down. So before, whenever I was explaining hertz, we are going up in units. Now we're going to go down. So like a meter, if you go to a millimeter, that's 1,000th of a millimeter or of a meter, and then you can go to a micrometer, which is a millionth of a meter, and then you go to nano, which is a billionth of a meter.
Wow.
So we're talking like 5 to 7 billionths of a meter.
And these like robot like thingies like
so this is not
literally
physical at this point, right? You're not getting a needle and you're not designing this. This is just the way that chemists have figured out that atoms can travel in silicon.
Yeah, you do stuff. Like I said, it's just like wizardry. Like it's like insane.
Wow.
So is it like chemical reactions or something?
They basically like a lot of the stuff they do is they kind of like basically they use chemistry to kind of like deposit the material in a certain layer and way to get like basically different materials whenever they are laid on top of each other, they interact a certain way.
Yeah.
And they basically just do that for like the entire thing. Like,
wow. There's a machine built by I think one company, the one that drops the tin and then it hits it with, it pretty much makes plasma, and then the plasma like bounces and it hits like the template wafer, and then like there's one company that makes this one machine which pretty much makes all chips.
Snapdragon, or is that a
no, it's
even like higher up from
Hey Bert, can you look up like all materials that are inside of a chip?
Because I know at some point recently Apple started making their own like M1, M2 chips, right, going up. So is that just they found a way to do it
that would
cheaper for them?
Probably be them designing the architecture of the chip, and it's most likely one of these machines from this company prints the chip.
Yeah.
But to come up, they probably came up with an architecture that works for the chip that has this many XOR gates and this combination to do these.
But I know within like a few years ago, they were like, I don't know about doubling, but they were really improving the productivity of these chips.
There's a
the
law
efficiency.
for it. It's not
Murphy's Law.
Is it Murphy's Law?
Yeah, but it's kind
Wait,
of...
is it, you sure it's Murphy's Law?
Or, no, Murphy's Law is
It's
anything
not Grover's.
that
Grover's.
will happen. Oh, what's it called?
There was some dude noticed that pattern, and he pretty much said that every X amount of years, technology will increase by this.
Yeah.
And that's one of the things for that is clock speeds of CPUs. Like now we're in gigahertz. Megahertz used to be crazy. Kilohertz used to be crazy.
Yeah.
So technology is exponential.
But we're actually hitting physical limits now.
Yeah.
It's broke. That's what he said. Like when he observed it, because he observed the trend when it was growing linearly, but we're actually hitting physical limits.
Really?
We can't fit. I mean, we already have billions of these little gates on a single CPU, where eventually you literally can't.
So there'll be a point where it stops.
We think, or they think,
I mean,
with our current technology of classical computing, which is what this is called. Yeah.
So will it kind of flatline, or will it be more like a bell curve? Like will it decrease?
So even like today, like we're getting to the point where it is like flattening out a lot, and like we're not so much as Moore's law. That's what it is.
Oh, okay.
We're not so much as improving like the speed as much as we are the efficiency. We're basically we're saying like, okay, we're gonna stay at the same speed, but take half as much power to do that.
Save battery,
basically, yeah. So that's basically in the last couple of years. I mean, maybe in the last year or two, probably. That's been where we've kind of hit a limit where that's where a lot of the actual there's been more like revelations or like more. They figured out how to make things more efficient rather than just faster.
Sure. Maybe
but
like
eventually there has to be a
using
limit
less
for that,
material or just taking less.
It's usually in the form of heat. Like if your processors get extremely hot, a lot of computers.
That's why they use water, right?
A lot of the size of computer comes from cooling. Well, that's probably not always true, but so as these CPUs, the heat is a form of waste. I mean, that's wasted energy. So as they can get these to naturally be cooler and less heat.
But eventually there has to be a point where they're giving off no heat, or like right, technology can improve eventually, like, it has to fly line
Technically,
somewhere, right?
whenever there's like excitation of electrons, there will be. I don't think there's a way where we can get out of.
Is that kinetic
dissipating
energy?
heat.
Is that the right term?
Technically, yeah, because it's the movement. It's like the energy of movement.
Yeah.
But like in reality, you can't. Basically, something can't not dissipate heat in some way unless it's at like 0 Kelvin or absolute zero, where everything just stops.
Freezes.
Yeah.
Okay, yeah.
So, to wrap up here, I think it'd be fun to kind of go around the circle and give off or give a hot take, or just like that has to do with something in the realm of technology. Like, for example, like in 10 years, I think we're gonna be here, or something like that.
I didn't think of this at all.
You can go last. Seth will start us out.
I didn't think of it either.
Brainstorm.
I would be in 10 years. I wouldn't be surprised. I don't know if this is against the grain of this question. I wouldn't be surprised if in 10 years we had something somewhat like Jarvis per person.
Per person.
Yes, I think that. Not probably quite as like, but like a personal assistant that's more
Like
active,
like a physical personal assistant.
because how Jarvis was always ready to conversation. I mean, you can see how close ChatGPT is, but something that's like an active. Now, do I want that? No, but I think that we have a lot of the technology that we would need to have like an active listener companion that's digital. I think that's super unhealthy for humans, but I think that we could see something that's like you always have an earbud and you can always just.
Well, yeah, mine. I just thought of this right now. It's not really a hot take, but it goes along with that. Is like smart glasses.
Right.
I think in the next 10 years, like it won't be like a phone. Okay, maybe like 20 years, it'll be very close to a phone as far as how many people have them. I don't know about if it'll ever get down like to a certain.
Because
like,
a big. Yeah, go ahead.
It's just like what you're saying. It could be an AI always listening, always watching, helping you with stuff. But
Helping.
okay, yeah, I don't know.
But the biggest hurdle for this is probably finding a way that they can transition stuff to computing on device, where like your phone's doing all the thinking, versus always needing a connection, because that's kind of the
right. But that takes so much area, and especially in smart glasses, you can't.
Right. That's why it's in the years in the future and not now. That's actually the difference between Apple AI or Apple Intelligence and as they try to do as much of the on-device computing
hardware,
as they can. And that's why it's so much worse than everything else.
Yeah.
Sure. I'll go next, then Zane can end it. I think that in 10 years, 8% of the of human beings on the planet will have a romantic relationship with an AI girl or boyfriend.
Like just
That's a hot
digital
take.
or
That's
like
a really hot take.
just digital or like Blade Runner.
I was thinking more digital, or just some form of.
Like all they can do is chat.
I mean, I don't know exactly what that will look like, but I think that 8% of humanity will have a romantic
That's a lot.
relationship.
That's 100 million people, right? Am I wrong?
In 10 years.
You think 100 million people are gonna have
Yes.
a relationship?
Yes. I do.
So like the metric for this is, I needed to have a better metric for mine. That 8% of people say the only love interest in their life is their AI.
I don't know about the only, like, I don't know, like maybe like they're cheating on their wife or something with like an AI girl.
Their primary love interest.
I have a feeling
Sure.
this isn't gonna age too well.
Sure.
Or age really well. Maybe it'll be
Good.
25%.
It could.
Oh,
One of us
so
in this
sad.
room.
Oh no.
Well, he's already taken,
Oh,
so
okay, well.
it's just one of us.
All right, Zane, what about you?
I think the current, kind of what Seth is saying, the current AI model is not sustainable. And I don't even think this is a hot take, honestly. I think this is just something that a lot of people don't realize is like OpenAI is losing out on so much money. Basically, kind of what their long-term goal is to get you effectively hooked on it.
Yeah.
So that way, whenever they do eventually increase their prices, because they're doing so many things at a loss.
Yeah.
And you can see that just in how ChatGPT's like progressed. Where like originally it was like you could do as much as you wanted for free, and then slowly but surely it's like, oh, to use the best model, you only have like 2 chats before you have to use a lower one, or you have to pay or whatnot, and eventually it's just gonna get so paywalled that like the base experience is not gonna be like really useful.
But people are going to be so hooked on the product that they can't do without.
Yeah. So I mean, the thing is, it's going to come to a head where eventually it's going to be like so non-profitable for the companies that they're going to have to charge so much, and the whole thing's just it's all just gonna collapse.
I can see that.
Like,
That's a good hot take.
Because it's called the AI bubble. I think they're calling it the bubble.
yeah,
A lot of people are.
That's interesting.
just like all of the other bubbles in history.
Yep. It's gonna happen. Zane the Prophet.
Yep.
Oh yeah.
We'll come back to this podcast in 10 years and everything will be in ashes and ruins. AI.
Let's hope not. Yep. Hey, thank you for coming on, Zane.
Yeah.
Wait. What's his hot take?
He did the meta
there's
glasses.
smart
right?
glasses. I don't know. I think it's not really a hot take. I just think they're going to be fine. I'll make it a hot take. We're going to, in 25 years, people are going to use smart glasses more than smartphones and hand gestures and potentially some sort of brain connection activity. I don't know.
Neuralink.
I hope not, but it could happen. I don't know. That's my hot take.
Maybe it's the boomer in me, but I don't want that.
No, I don't either.
I don't either.
I think
don't-
phones are a good
yeah.
stopping point to where we don't need too much faster or too much more immersive of an experience. But
Yeah.
I don't see a world in which I don't want to interact with my phone like this.
right,
You know what I
yeah,
mean?
on my face. I mean, for some instances, it'd be nice. You can just move your eyes and control things.
I give you 1 year before you're wearing meta glasses every day.
I mean, I like the idea of them, but yeah, I'd rather just keep a phone.
I will say, you can turn on eye tracking on your phone, and it is weird. I've also used the Apple Vision Pros. Eye tracking,
Dude,
it literally is the most powerful feeling.
Speaking of eye tracking, unless you have more to go with that, I saw a video, and this could be kind of false. I think it's mostly true. And if you scroll deep down in the Instagram and TikTok terms of service, you can see where you're agreeing by deciding to agree to the millions of words, whatever you're agreeing to. It's allowing it to use your rear front camera to look at where your eyes are looking on your screen, and it uses that data where your eyes are looking on the screen. Like if you're watching a car video and you look up at the sky or looking at different parts of the screen, it can realize what you like more in that video and then push out more of that in the algorithm. I'm pretty sure that's true. I could be wrong, but I think you're agreeing to that when you agree to the terms of service. So they are using your camera.
Man.
I don't know if I necessarily tested it, but if you I don't know a good example of what that would be.
Look at birds in every video. All your reels become birds.
Yeah, I mean maybe I don't know for sure, but I think it makes sense too that they would do that if they can do that. But
You should try it. It's somewhere buried in your sentence. You can Google it and you can look at things. And if you look at an app longer, the thing with eye tracking, in the Vision Pro, it's you think you'd have to think about it. You don't.
yeah.
I look at the icon and it's selected.
Wait, you've tried the Vision Pro?
Yeah.
Wait, actually?
I did a demo at an Apple store.
That's
I mean,
sick.
and it's just blows your mind because you think well, it might be inaccurate. No. It's whatever you're locked on. It's it.
But if you accidentally look past something, it's not going to do it. You have to have a second
It just
staring
knows. I mean, it's the weirdest thing. You're I want to open the Photos app. You literally just and it's open. You can just snap it too. I don't know. It's weird.
That is crazy. I've never tried them, but yeah, that's gonna be
Stuff
crazy.
like that. When
our kids are going to have a crazy
we're
life.
Yeah.
All right. Any more topics? Anything you want to close with, Zane?
Not that I can think of. I could talk on so many other things we talked about earlier forever, so
Yeah.
gotta cut me off at some point.
Yeah.
Now, this was for myself, a very learning experience.
Yeah,
Definitely expanded my brain. My head hurts.
Yeah. Well, good luck with your project.
Yeah.
Yeah.
Good luck.
Have to get us an update.
Yeah.
I was planning on starting it. I was actually, the reason why I was slightly late, which you weren't even here, I don't think.
That's my room.
Oh, you were? Okay. I was looking all over for my house because we just moved back. I moved back in January, but I haven't looked through all the stuff I've moved yet. And part of the project is setting up my Raspberry Pi to be a server to basically ping the phone number to then translate it onto the screen, and I can't find it.
Oh.
It's like missing. Like
Oh,
I
no.
looked everywhere. I cannot find it.
Is that your parents' house, you think?
I don't know.
Huh.
But
Can you get one in time?
I mean, her birthday's on June 2nd, so
Oh, okay.
I've got plenty of time. But like it was gonna be like a weekend thing where like I wanted to build it like this weekend and then like maybe improve on it.
Actually,
like,
this
closer to
episode
her
will
birthday.
definitely be aired by June 2nd.
Oh yeah, I want to like have it made and
Okay,
give
sure,
it to
sure.
her
Mhm.
by.
Yeah, that's a really good
You can
idea.
also just not tell her. You can just tell her, no, you can't do that because that's lying. Just tell her, don't listen to it.
Where were you at tonight? Not recording a podcast. I'll tell you after your birthday.
Or we really could wait to post it too. Like
No,
We
I think
cannot
it'll be
wait.
fine.
We cannot wait.
My goal is to get it done like this weekend,
Okay.
but
Wow.
that depends on a
Sick.
lot of things.
Mm-hmm. Yep.
All right. Well, good luck with that.
Yeah.
Yep.
Thank you.
Thank you for coming on.
Come on.
Thanks for having me.
The outro music.